Hello everybody, we're going to do some quadratic equation solving. Um, it's a little bit different than solving linear equations, but not too difficult when you keep in mind that these are quadratics, right? Quadratics are four-sided objects. So we're going to make these all into squares to be able to solve them. So first up, let's just do our really basic x squared is equal to 9. So if I turn that into a square, and I say, well, this is x squared, right? So the area of this needs to be, x times x. So what two numbers do I multiply together to get 9? Well, I could multiply 3 times 3 together to get 9, right? So x equals 3 is a solution that would make this statement true, right? 3 squared is equal to 9. But there is another solution if we include all the numbers, right? So we could include negative 3, so x could be equal to negative 3, right? Because negative 3 times negative 3, or negative 3 squared, is also equal to positive 9. So with quadratics, you will see that we end up with two solutions. Sometimes one and sometimes no real solution, but in general, we usually end up with two solutions. Okay, so let's go on to the next level. Level 2. So now we have something squared is equal to 9. Well, don't let all this stuff in the parentheses confuse you. It's just something, right? Something squared is equal to 9. So that something should be equal to 3 or negative 3, just like in my previous problem, right? So x plus 1 is equal to 3, or x plus 1 is equal to negative 3. And that just makes this square right here where it's x plus 1 times x plus 1. And if I were to actually multiply this out, x times 1 is x, this is x times x, which is x squared, and x times 1 is x, and 1 times 1 is 1. So that is actually equivalent. I could write an equivalent expression if you remember from our previous module. It's equal to x squared plus 2x's plus 1 is also the same. It's an equivalent expression to x plus 1 quantity squared. Alright, so x plus 1 is equal to 3, or x plus 1 is equal to negative 3. So if I want to find out just the value of x that makes this statement true, now I just do my regular old equation solving, right? So I just subtract 1 from both sides. So this is equal to 3 minus 1, which is 2, and this is equal to negative 3 minus 1, which is negative 4. So if I were to plug these values in, it would make this statement true. So 2 plus 1 is 3, 3 squared is 9. Our negative 4 plus 1 is negative 3, negative 3 squared is also positive 9. So these are my two solutions. Okay, let's go up to level 3 now. So now I have a statement which is not a perfect square, right? I have x squared, and then I have 6 x's, and then I have 9, and then I have this 49 over here. So it would be really nice if I could turn it into something like this, where it's just blob squared equals 49. I could deal with that, right? So when it's not in the form that you like, let's force it, right? So let's turn it into a square. So when we multiplied these polynomials together, remember we had x squared, and then we had, we're multiplying a couple of x's on this side and this side, right? And it looks something like this, and then we have our 1's to fill in the spot over here. So this one might make a nice square if it turned out something like that, x squared plus 4x's plus 4. But now I have 6x's plus 9. So really what you do is, so we have x squared, and then we have 6x's, so I need to split that into two categories, so that would be 3x's here and 3x's here, right? It would be a total of 6. Now, when I multiply x squared, I need to multiply x times x, right? And then when I multiply x times something that makes 3x, that something better be 3, right? So x plus 3 times x would be x squared plus 3x. And then also this way, right? X times something equals 3x. That must be 3, right? And now I do have my perfect square, x plus 3 times x plus 3. And now I need to fill in that last spot right there. So 3 times 3 is equal to 9. And luckily, that's exactly what I have right there, right? So x squared plus 6x plus 9 is the same equivalent expression to x plus 3 quantity squared, right? And now I have this situation where I have something squared is equal to 49, so that something has to be 7 or negative 7, right? 7 times 7 is 49, or negative 7 times negative 7 is also 49. X plus 3 equals negative 49. Oh, 7. This should be 7. Or negative 7. Oops, ran out of paper there. Okay, so subtract 3 from both sides, and I get x equals 4, or subtract 3 from both sides, I get x equals negative 10. Okay, so those are my two solutions. And I could check, let's just plug in one of them to check it. So let's say 4 times 4 is 16, and then 6 times 4 is 24, and then 9. So 16 plus 24, that's 10, so 30, plus 10 more is 40, so 40, that makes 40, plus 9 is 49, so that checks out. Okay, and if I check negative 10, I would wager that it would also work. Okay, let's just do one more for this video. So now we have x squared plus 2x plus 3. So it's not in that square pattern. Let's force it to be a square, right? So maybe I'll draw a little bigger this time. So x squared, and then my 2x's I want to split in half. So looks like I can do that into x and x, makes 2x. So this would be x times x, and x times what gives me x? Well, it's just a 1. And same thing this way. So x plus 1 times x plus 1. So it's x plus 1 quantity squared. But I want, let's see, 1 times 1 is 1. But it's not a 1, it's a 3. So I want to force it to be a 3. So let's take away 3 and add a 1, right? So take away 3 and add a 1 to both sides. So that would be negative 2, right? So equals negative 2. Now, when I have something squared is equal to negative 2, it's actually, there's no way something squared could be a negative, right? It's always a positive. So this is no real solution, is actually my answer. But there is an imaginary solution, so let's just for a moment assume that we can take the square root of both sides. So we would have x plus 1 is equal to the square root of negative 2, which I'm going to say is the imaginary square root of 2. Or I could have the negative, right? The negative imaginary square root of 2. Okay, so then I just subtract 1 from both sides. And it's really 3 sides here. So I have x is equal to negative 1 plus the imaginary root of 2, or negative 1 minus the imaginary root of 2. So there's really two solutions, but they're not real solutions, they're just imaginary solutions. Okay, so that's enough for this video, but we'll go ahead and jump on to even higher levels of solving quadratic equations. And it all works together if we just remember to make this into a square. So we'll see that in the next few days.